This defines the range of hyperparameters that we want to test for our support vector machine, SVM. We have 4 options for the regularization parameter, C, 4 for the kernel coefficient, gamma, and 2 kernel types, RBF, and linear. This defines the range of hyperparameters that we want to test for our support vector machine, SVM. We have 4 options for the regularization parameter, C, 4 for the kernel coefficient, gamma, and 2 kernel types, RBF, and linear. This defines the range of hyperparameters that we want to test for our support vector machine, SVM. We have 4 options for the regularization parameter, C, 4 for the kernel coefficient, gamma, and 2 kernel types, RBF, and linear. This tells the RandomizedSearchCV how many random combinations of hyperparameters to try. We are only going to test 5 combinations out of all the possible combinations, not all of them. This tells the RandomizedSearchCV how many random combinations of hyperparameters to try. We are only going to test 5 combinations out of all the possible combinations, not all of them. This tells the RandomizedSearchCV how many random combinations of hyperparameters to try. We are only going to test 5 combinations out of all the possible combinations, not all of them. Because n_iter_ is set to 5, RandomizedSearchCV will randomly select and evaluate only 5 of the possible hyperparameter combinations. Because n_iter_ is set to 5, RandomizedSearchCV will randomly select and evaluate only 5 of the possible hyperparameter combinations. Because n_iter_ is set to 5, RandomizedSearchCV will randomly select and evaluate only 5 of the possible hyperparameter combinations. After evaluating the 5 random combinations, RandomizedSearchCV will pick the one that performs best, based on whatever scoring metric you've chosen, which isn't specified in this particular problem, but it's important to know it exists. After evaluating the 5 random combinations, RandomizedSearchCV will pick the one that performs best, based on whatever scoring metric you've chosen, which isn't specified in this particular problem, but it's important to know it exists. After evaluating the 5 random combinations, RandomizedSearchCV will pick the one that performs best, based on whatever scoring metric you've chosen, which isn't specified in this particular problem, but it's important to know it exists. The parameter grid defines the possible values for each hyperparameter in the support vector machine, SVM. It includes C, gamma, and kernel, representing the regularization parameter, kernel coefficient, and kernel type respectively. Each has several choices, creating many potential SVM configurations. The question then asks us to consider how a randomized search process would explore only a subset of these options. Isn't that interesting? This line sets the parameter n_iter to 5. In the context of RandomizedSearchCV, this dictates that only 5 random combinations of hyperparameters from the parameter grid will be evaluated, not all possible combinations. This is a crucial aspect of a randomized search. It trades off computation time for finding a good enough solution instead of guaranteeing the best possible solution. This trade-off, isn't it brilliant? RandomizedSearchCV is a technique used to efficiently explore hyperparameter spaces when dealing with many possible combinations. Instead of trying each combination, it samples a random subset of combinations. This is much faster than exhaustively trying all possible combinations, especially for large hyperparameter grids. The key here is randomness. It does not guarantee finding the absolute best hyperparameter combination, but it is very good at finding a good combination much more efficiently. Because n_iter is set to 5, RandomizedSearchCV will only evaluate 5 randomly selected combinations from the 32 total possible combinations created by the parameter grid. The specific combinations selected are unpredictable due to the inherent randomness of the algorithm. Each execution with the same settings will yield a different set of 5 combinations. Quite random, right? For each of the 5 randomly chosen hyperparameter combinations, an SVM model is trained and evaluated using a scoring metric, not specified in the problem. This evaluation provides a performance score for each model. This could be accuracy, precision, recall, or some other suitable metric depending on the problem, but it's not important for this quiz. After evaluating all 5 models, RandomizedSearchCV selects the model that achieved the best score according to the chosen evaluation metric. This model is considered the best performing model among the 5 sampled, not necessarily the absolute best model over the entire hyperparameter space. This question sets the stage. It introduces the machine learning context, using RandomizedSearchCV, a scikit-learn tool, to optimize an SVM classifier. The focus is on understanding how this tool works, specifically the impact of the _n_iter parameter. This is a multiple choice option. It proposes that a fixed number, 16, of model combinations will be tested. This is incorrect because RandomizedSearchCV doesn't test all combinations, it samples a subset. This option suggests an upper bound on the number of evaluated models. It's partially true since, while there are more possible combinations, only a subset will be sampled due to _n_iter. But the maximum is actually 32, not 16. Let's explore this further. This statement is about the diversity of models sampled. It posits that at least one model using each kernel type will be included in the sample. This is not guaranteed because the sampling is random. This option explains the selection criteria. It states that the algorithm picks the best performing model based on a metric, not specified. This is true. RandomizedSearchCV always chooses the top performer from its sampled set. This line defines the hyperparameter grid. It shows the possible values for C, gamma, and kernel that RandomizedSearchCV will consider. C and gamma are SVM parameters. Kernel specifies the kernel function type. The total number of combinations is 4 times 4 times 2 equals 32. This highlights a key aspect of RandomizedSearchCV. It samples randomly from the provided hyperparameter space. It does not exhaustively try every combination. This describes the process of assessing how well each sampled model performs using a specified scoring metric. The performance is evaluated on a dataset not specified in the question but essential for the algorithm to work. This is a meta-statement, indicating that what follows is a multiple-choice question to test the understanding of the previously explained concepts. This parameter controls how many random samples RandomizedSearchCV takes from the 32 possible combinations. Here, only 5 combinations will be randomly chosen and evaluated. After evaluating the sampled models, the algorithm selects the model with the best performance according to the predefined metric as the optimal model. This refers to the machine learning technique used to find the best combination of settings, hyperparameters, for a support vector machine, SVM, classifier. RandomizedSearchCV is chosen because it efficiently explores a large range of potential settings without testing every single possibility, unlike a grid search CV which can be computationally expensive. We're looking for an optimal balance between performance and computational cost. This defines the different settings, hyperparameters, to explore for the SVM. The grid includes the parameters C, regularization strength, gamma, kernel coefficient, and kernel type. Each parameter has multiple options. C has 4 choices, gamma has 4 choices, and kernel has 2 choices. This makes up a vast search space for the RandomizedSearchCV to work with. Think of it as a menu of choices for each of these aspects of the SVM we are trying to optimize. This crucial parameter in RandomizedSearchCV specifies that only 5 random combinations of settings from the parameter grid will be tested. In other words, out of all the possible parameter combinations, only 5 will be selected and evaluated. Instead of examining every possible combination, which could take a long time, RandomizedSearchCV randomly picks 5 choices to test. This is a great way to explore several options quickly. Because we've set _n_iter equals 5 RandomizedSearchCV will randomly pick 5 combinations of the C, gamma, and kernel parameters from the entire parameter grid. The selections are completely random. It's like drawing 5 lottery tickets from a large pool of potential winners, where each ticket represents a unique set of hyperparameters. Based on the n_iter equals 5 setting, only 5 unique sets of hyperparameters will be chosen at random from the many combinations of C, gamma, and kernel for testing. Remember, the random selection doesn't guarantee that any specific feature or value is selected. These 5 combinations define the models trained and evaluated in this step. After choosing the 5 random hyperparameter combinations, an SVM model is trained using each combination. Then each trained model is tested on the data, and its performance is measured using a specific evaluation metric, not specified in the problem, but that's okay. Essentially, we build 5 different SVM models using different settings and compare their performance in order to find the best one. Once all 5 models have been trained and evaluated, RandomizedSearchCV selects the model with the highest performance score based on the chosen evaluation metric. We choose the model from the 5 that did the best on the test data. The selection criteria are implicitly given by the algorithm's scoring. This is the core question of the quiz. It requires you to understand how the n_iter parameter in RandomizedSearchCV affects the search process, and to analyze the possible outcomes of randomly sampling hyperparameter combinations. The question assesses your comprehension of the RandomizedSearchCV algorithm, not just its result. This statement is incorrect because RandomizedSearchCV with n_iter equals 5 will evaluate only 5, not 16, combinations. This is incorrect as well. The maximum number of combinations that could be evaluated is 32. 4 choices of C*, 4 choices of gamma*, 2 choices of kernel. But only 5 will be evaluated in this case. This is false because the selection is random, meaning there's no guarantee each kernel type will appear in the 5 chosen combinations. The parameter grid defines the different settings, hyperparameters, we want to test for our support vector machine, SVM, model. It's like a recipe book, with different ingredient combinations, values for C, gamma, kernel. We have 4 options for C. 0.1, 1, 10, 100. 4 options for gamma. 1, 0.1, 0.01, 0.001, and 2 options for kernel. RBF, linear. The total number of possible combinations is 4 times 4 times 2 equals 32. This tells RandomizedSearchCV to only randomly test 5 of the 32 possible combinations from the parameter grid. It's a time saver. Instead of exhaustively checking every combination, it samples a subset, improving efficiency especially when dealing with many combinations. Because n_iter is set to 5, RandomizedSearchCV selects 5 different combinations of hyperparameters randomly from the 32 possible combinations. It's like drawing 5 lottery tickets out of a total of 32 tickets. There is no guarantee of selecting all possible kernel types or combinations of C and gamma. RandomizedSearchCV trains and evaluates 5 different SVM models. Each model uses one of the randomly selected hyperparameter combinations. The evaluation uses a scoring metric to assess how well each model performs. Think of it as a taste test of 5 different recipes. After training and evaluating the 5 models, RandomizedSearchCV selects the model that performed best according to the specified scoring metric. It's like selecting the best tasting recipe from our taste test. This line sets the n_iter parameter to 5. NITER controls how many random combinations of hyperparameters are tested. In simpler words, it tells the algorithm to try only 5 different combinations of settings out of all the possible ones, instead of checking every single possible combination, which would take way longer. This is a description of what's happening. The algorithm isn't trying every combination of C, gamma, and kernel from the parameter grid. Instead, it's randomly selecting 5 different combinations to evaluate. Because n_iter is set to 5, the algorithm randomly picks 5 combinations from the total possible combinations, which would be 32 in this case. Think of it like drawing 5 tickets from a lottery. You don't know which numbers you'll get until you draw them. Here, the algorithm builds and tests the 5 randomly selected SVM models, each with its unique combination of hyperparameters. The goal is to see which one performs best according to the scoring metric that is being used.